Let's do problem 1 on practice exam 2. So this is the question. It's kind of like problem 1 on the first exam in that it's really simple, but it maybe looks complicated because there are lots of letters. So let's just look at part A here. So we've got a formula for the volume of a cone. So it's a right circular cone, but that just means that it's the usual cone that we normally call a cone and not something crazy. It says R is the radius of the base and H is the height. Okay, so we could draw a picture of a cone, but it wouldn't really help with this problem. So A says find the rate of change of the volume with respect to height if the radius is constant. Okay, so what this basically means is we're going to pretend like R is a constant. Okay, so in A here, let me copy down the formula. So the formula is V equals pi r squared h over 3. Okay, so in this first problem we're going to pretend that the radius is just a number. So pretend like it's 2 or something. You can even just write it as 2 in your formula if you want, and then take the derivative and then put it back as r after you get done. So what we want to do is we want to find the rate of change. So you know the rate of change is the derivative of the volume with respect to the height. So that just translates really naturally into the notation we use for the derivative. So we're looking for the derivative of volume with respect to height. Okay, so h is going to be the variable, and we're going to pretend like r is just some number. Okay. Alright, so this means that this other stuff, this pi r squared 3, this is just some number times h, right? So what happens when we have a function and we just have some number times the variable? We take the derivative, what's left is just the number, right? So everything in this expression is going to vanish except for h, which is the variable. So the answer is pi r squared over 3. And that's it. Okay, so really easy. And now let's go into part B. So for part B, we're going to do something similar. Still going to find the rate of change of volume, but this time it's going to be dV dr, and we're going to pretend like height is a constant. Okay, so let's rewrite the formula. V is equal to pi r squared h over 3. And I did something wrong because volume... Okay, alright, that's right, that's the right formula. Okay, so now what we want is the derivative of volume with respect to r, and we are going to pretend like h is a number. Okay, so maybe I could rewrite this if it makes it more clear as pi h over 3, which is just some number, times r squared. Okay, so now we're going to pretend like this is just a number and r is the variable. So what happens when we take the derivative? We get pi h over 3, you know, the coefficient or the number just stays there, times 2 times r, and that's it. That's the answer.